Okay. Thanks, Marilyn. Good morning, everybody, or afternoon, depending on where you are. I'm going to go ahead and jump right in and get started. You've heard about who I am already. I'm going to be talking today about, how to future-proof your fleet in an ever-changing environment and landscape. So I'm going to go over some of the industry trends, emerging trends, some of the potential challenges that they may have for folks managing large fleets of vehicles. And the importance of keeping up with the different, being abreast of the different technological changes out in the world that are happening today. I'll take a deep dive into some of the newer technologies and, understanding how to implement those solutions. I'll go through, exploring how to optimize your fleet's long-term performance, right? It's understanding to getting the data out of the systems that you need to optimally manage your fleet. Current standard KPIs today, what are the future KPIs you might need to be aware of, and obviously the impact of using data, right? Keying in on data for decision-making processes, and then go over a few examples. So I'll go ahead and jump right in. Understanding the changing industry, right? There's a lot going on out there in the world, and whether it's fuel cell or combustion engines, don't rule out hydrogen. It's a limitless energy, right? And efficiency and safety in electrolysis systems, transfer processes, and the fuel cells themselves have evolved significantly. One really cool anecdotal story that was relayed to me by a bunch of engineers is how hydroelectric dam systems can be used for the process of electrolysis, and one of the technical issues that has always been a problem for dam engineers is the aeration of water and affecting the impact it has on the wildlife. And so there's been recent engineering solutions that actually solve that problem of aeration of water. And then another problem is the hydroelectric dams, they have to spin up and spin down their turbines based on energy demand. Well, if you take those two problems and effectively, you don't have to worry about the aeration of water anymore and the impact on wildlife, and you can run those turbines full speed constantly. One, that saves impact on maintenance, because spinning up and spinning down the turbines in of itself puts extra stresses on there and relates in more costs. But when off-peak hours at night and that turbine spinning full speed, that excess energy can be used to actually perform electrolysis processes, which the hydrogen obviously used from that can be used for fuel cells and hydrogen combustion engines. But then in turn, even the oxygen can be used to build iron oxygen batteries. These are massive data warehouses that store energy. So it's kind of this win-win-win-win scenario that I've been told this story multiple times, which makes me think, don't rule out hydrogen for future and energy storage systems. So overshadowed, somewhat biofuels. They've been around for over 100 years and they remain a factor regionally and locally. But, biodiesels, there's always ongoing debates and lobbying efforts regarding their scalability, sustainability, and competition with food generation, right? It's an interesting discussion that at scale, biodiesels are the only alternative fuel that actually could have an impact on, food scarcity concerns. So that all said, for some of the different alternative energy sources out there, EVs seem to be the winner of the next energy delivery system, at least for the near future for vehicles, right? But they too have their own challenges. Infrastructure is not fully in place. Environmental impacts of lithium extraction, is a real scenario. But more kind of pressing and pertinent for today for fleet managers is the immediate challenge of training technicians, right? And understanding safety protocols of EV vehicles, and also the fact that, it seems likely that the industry is going to eventually convert over to 48-volt architecture, and what impacts does that have for technicians and the safety, right? As it pertains to autonomous vehicles, while they're not necessarily mainstream today, there's no doubt, right, that they're here. And how many times do you see car manufacturers advertise some level of autonomous driving today? And if you live in the Phoenix or Tempe area, you're already seeing Waymo driverless taxis all over town, right? And so they're here. Nobody thought a computer would ever beat a human at chess, right, or Go or Jeopardy, but until they did. So it's a function of time. And while Tesla's autopilot is still technically designated an SAE level 2 driving autonomous system, it recently hit 1 billion miles in full self-driving mode. And since 2019, while the autopilot was engaged, there was one crash for every 4.85 million miles driven. When the autopilot was not engaged, there was one crash for every 1.4 million, right? So they're demonstrating better driving capabilities than us mere humans. And there's always more to the story, but even as further analysis potentially lowers that ratio between human and autopilot miles per accident, it's a significant statistic. So, and the perceived challenges, right, from 3 or 4 years ago seem to be waning in terms of things like public acceptance. At the very least, autonomous vehicles are everywhere in Arizona, and nobody seems to be squawking about them. There's infrastructure issues. These now seem to be more on the OEM side, since Tesla has gone all in with camera systems versus LiDAR systems, and they have a full end-to-end neural network that is mapping out the world. And so, accordingly, Tesla, they're very bullish on full rollout of self-driving vehicles in the near future. And so, I guess in the end, while not quite ubiquitous across America, seeing self-driving vehicles roll out across the country is something we'll probably see all within our careers. As it pertains to, connected vehicles and the Internet of Things, right? Obviously, vehicle telematics systems have been around for a long time, but their adoption and maturity have exploded in recent years. And as these systems evolve, it's becoming more accepted that they aren't so much about Big Brother, but, more and more about safety, operations, and vehicle diagnostics. And, as the legitimate privacy concerns are being addressed, it's seeming that employees and unions alike are less worried about the use of vehicle telemetry tools. A lot of the data available today from onboard sensors like LiDAR, radar, ultrasonic accelerometers, and what have you, it remains proprietary to the OEMs, but the OBD2 ports, right, and the aftermarket telematics devices that plug into them allow for the collection of mass amounts of data, right, on the petabyte, exabyte scale. And it's these large data sets that are now showing their predictive maintenance potentials. And I'll speak to more about that in another slide. But on the horizon too, other technologies, this too is more of an engineering problem at this point, but the concept of vehicle to grid solutions, right? If all of America's fleet was overnight EV, right, and roughly 300 million vehicles, and that average vehicle can store up to 80 kilowatts, that's 24 billion kilowatt hours of energy, right? It's enough energy, storage in those vehicles to run America for 3 days, right? Loosely equates to the energy consumption of all the households. So a vehicle grid solution, its ability to push that energy back into the grid as needed would help offset, an already strained infrastructure. And albeit, maybe this is something that's some years away, it's still a technology that's to be aware of in the coming future. And then there's, generative pre-trained transformers, large language models, all the things, artificial intelligence that is the rage today. But how it will, how will things like large language models really transform the fleet industry? Remains to be seen and probably somewhat hard to predict right now. But what I think is easy to predict is that it will have a major impact, right? Just kind of one example as it relates to all that and future technologies, the proposed OBD3 protocol would actually wirelessly transmit emissions data in real time from a vehicle to roadside antennas, eliminating the need for inspections, right? And only taking a vehicle out of service if particular trouble code necessitated it being pulled out of service. And understanding security concerns loom around those kinds of things. My sense is the reality is if you own a smartphone today, you've already given up on that battle. So the ability, as an example too of the natural language models, right? Your ability to say something like, what are the top 5% most utilized and bottom 5% underutilized vehicles in my fleet? Or to say or type a question, what is the optimal life cycle for our F550s operating cold weather climates with 30% off-road use, right? And then to receive back actionable data, right? Insights that you would actually want to follow up on and validate. That capability is already here today. It's just simply an engineering issue to connect those tools against fleet-centric data sets. And kind of a stream of consciousness, just thought experiment to think about. If vehicles are parked still today, 95% of their lifespan, what happens when full self-driving vehicles, allow for vehicles to be rented while not used, right? Is it possible that city and county agencies, which own thousands of vehicles, could find a revenue stream from managing their own autonomous Uber-like fleet, right? So could mobility become a utility and fleet revenues, become revenue generating like their big brothers and sisters, the water and electric utilities. And this is just kind of simple math here, but if you had a fleet of 550 vehicles that each were quote unquote Ubered 5 times a day and say maybe a minimum of $10 a trip, that's over $10 million in revenue for a fleet organization, at no additional capital cost pertaining, to the cost specific of a vehicle. The only additional cost might be, the additional preventative maintenance necessary, and what have you. And once Class 5 full self-driving is really here, it's not even an engineering issue. You could simply add, the city county vehicles to a Waymo app or Uber app, and you're in business. So it's just kind of, maybe pie in the sky, something to think about that could be a reality in the future. In terms of leveraging technologies and upcoming technologies, right? As it pertains to the frenetic adoption of EVs, significant investment is necessary in substation upgrades and other, infrastructure elements. And, these need to be determined years in advance and improvements scheduled with already overburdened utilities, right? It's also kind of interesting that the electric vehicle industry effectively evolved around the retail consumer. And it's only recently that, factoring the unique requirements of large government and private fleets that have even been taken into consideration. Simple things like recording a meter reading during a charge session was not considered a couple of years ago. And so fleet-centric behind-the-fence charging needs are unique to city and county organizations. And the days of facility departments giving away free electricity to the public and employees alike are quickly coming to an end. So accordingly, it's critical to factor your kilowatt hours of cost into your asset's total cost of ownership. No different than any other fuel, right? This data provides valuable insights, when comparing ICE versus EVs in terms of the role they serve within the organization, their utilization, their downtime, and again, total cost of ownership. And also accordingly, the fleet management systems that folks use, and they need to capture charge transactions no different than an ICE vehicle does. It's a huge cost in operating a fleet. EV should be treated no differently. And the concept is you change to the terminology of energy type, right? So you might have a plug-in hybrid electric vehicle that one transaction is UNL for unleaded for its energy type, and the next is kWh for kilowatt hours, and they're treated with equal importance. So charging is also a different paradigm, right, than fueling regular ICE vehicles. So real-time awareness of the charger status, vehicle state of charge, fluctuating utility rates, reservations of ports, right, load balancing, energy distribution among ports, auto shutoff of charge sessions based on unique organizations defined parameters. They're all new concepts, not previously really concerning or applicable to EVs or to ICE vehicles. As well, chargers need to be treated, as assets themselves. They tend to break, right? And they need to be serviced more regularly. And you need to have insight into that information, that history of those fixes and repairs. So bottom line, as there are significant infrastructure investments beyond, the capital investments of EVs themselves and, beyond just taking longer to charge, there are multiple additional parameters to factor when rolling out EVs to the fleet, but good, bad, wrong, right, indifferent. The electrification of fleets is happening, and so it's something organizations most certainly need to prepare for. Okay, from telematics perspective, right, telematics solutions, they're maturing. They've been around for a long time, but they're really coming into their own in the last few years, and they provide a wealth of data. And just a small sampling of the kind of data that they provide, and this is not limited to, but real-time location awareness of a given asset, a group of assets, your entire fleet, as well as the historical awareness of where vehicles have been. And then the driver behavior statistics around them. So they'd be able to look back in time and to see who was speeding, heavy braking, lane departures, stop sign violations, right? And then from the health and longevity of the asset itself, and potentially how that pertains to driver behavior data as well, but diagnostic alerts, and more so now on the predictive side of the house. And I'll speak a little bit more of that in a bit, but using the data to analyze and portend failures. Forward, rear, and cab-facing camera systems with AI. My next slide, I'll talk a little bit more about that, but those are all a factor in today's fleet world. Secure fueling systems. So one device to rule them all. Many fleets face a scenario today where they have a device in their vehicle for fuel management, for telematics, and maybe even multiple telematics devices in a single vehicle. But more so vehicles are supporting just one device to do all of those functions. And then driver ID data. So the ability to leverage an organization's assigned HID card to get into a vehicle and then to approve access and authorization to be able to operate that vehicle. And then a history of who drove what vehicle when. And the ability then to integrate all of this telematic data with your fleet management solution as a single source of truth, right? So that if you have, if you create a new vehicle in your fleet management system or add new drivers and employees, those data should automatically synchronize with your one or multiple telematics solutions and eliminating the need for dual entry. And these days, insurance companies, they may offer lower rates for fleets demonstrating through data good driver behavior scores. So, having access to that data is paramount. From OBD2 ports, including, trouble codes, or incoming trouble codes can be selectively filtered and actioned based on organizational rules. So, for example, create a service request for a minor issue to be checked at the vehicle's next servicing appointment, right? You can offload, that issue, but you want to be aware of it and look at it, but it might not be paramount in terms of the operations or safety of that vehicle. So the next time it comes in, take a look at that and automate the workflows to make sure it does happen, right? Or automatically create a work order, based on the nature of what that code is. If you're losing oil pressure, you got a temperature indicator, automatically create a work order with high priority, send a text message to the driver of the vehicle and an email to the shop supervisor so that they can coordinate bringing the vehicle into the shop immediately based on the severity of that code triggered. Saving one engine has, saving an engine has been demonstrated to pay for smaller fleets a full year of the telematics solution. So in many cases, these systems can pay for themselves. All of these features, right, they help lower risk, improve safety, lower operating costs, they lessen downtime, and increase longevity of any given asset. And I'll speak more about this in an upcoming slide, but sharing these data with your fleet management system is an important aspect of future-proofing your fleet. So specific to the AI systems, the camera systems in cab and the rear and forward-facing cameras, they're getting better at what they do all the time. Today, in real time, they can detect distracted driving, right? Somebody's eating, smoking, they're sleepy, seatbelt violation, and they can provide audible, alerts to correct those bad behaviors. And the AI systems today can read stop signs and report violations, and the same for red light violations. And it's really just a function of time before the AI models are trained that these AI systems are basically going to be able to read any sign on the road. And what we do with that data, time will tell, but no doubt that's coming. And, leveraging forward, rear, and facing camera systems in conjunction with all the other data, right, the G-force data, and the timelines around that, all of this other telemetry data, you effectively know what happened moments after some event or accident occurred. Anecdotally, I've heard dozens of stories, whereby an individual in the world made a claim against an organization's driver, right, only for those claims to sheepishly have been, retracted once the camera system's data showed otherwise. So in the end, data doesn't lie. Camera systems tell the truth. And so, these solutions, they foster better driving behavior, they exonerate drivers when situations occur, and they collect a wealth of diagnostic data, resulting in lower vehicle costs and extended longevity of the vehicles. So talking about, mobility and being able to interact with a fleet management system anywhere you are in the world, traditionally fleet management systems are relegated to the shops, right, and fleet employees. But with the advent of smartphones, a little over a decade ago, it's empowered drivers alike and administrators and any other folks who need access to be able to work, from a tablet or a smartphone. The ability for drivers, for example, to do pre-post trip inspections, right, to submit service requests, update meter readings, look up a vehicle status if it's in the shop, or record, commercial fuel entries when they're filling their vehicles on an extended trip they take, and record accident details, right? Your ability that if you're in a minor accident to immediately take video, pictures, record road weather, witness information at the scene, right, and have all of those data immediately entered into the fleet management system in real time effectively. That also automates workflows, right? It might automate a work order or subject subrogation processes, right? And sending all that relevant data over and sending the relevant notifications, it's a huge time savings for fleet employees and drivers alike. And also, historically, shop technicians either, shared a computer or, among a couple of bays, right, that walk some distance to enter their information. Now cheap tablets can, be individually assigned, or, employees are allowed to use their own device. This inherently improves, shop technician efficiency. Additionally, leveraging modernized HTML5 responsive design, UI, UX techniques, right, all incorporating touchscreens, allow for the intuitive and expedient assignment and completion of work, right? Real-time labor capture is as quick as you look on your phone, you got a work order assigned to you, click start on that task and you're charged in real time. When you're done, you click stop and you're done working on that work order and the next job gets assigned to you. It just makes it really easy and intuitive. Many less clicks than years prior. So bottom line here, expanding the use of your fleet management system to drivers and operators alike allows for the collection of a wealth of additional pertinent information, and there's significant value in the ability of your shop personnel to be able to communicate directly with drivers in the field. So from optimizing fleet and efficiency, performance, data is everything, is the bottom line. and having a fleet system that supports intuitive, easy entry of all the necessary supporting metadata is paramount, right? For example, from a manual entry perspective, can the technicians seamlessly enter, the data, post parts, labor, commercial, but at the same time through configuration and automation, all of the necessary metadata, things like markups, taxes, overtime, downtime, delays, priorities, right? All of that is then automatically recorded again, just through workflows defined. And then from a data perspective, your ability to have tools that can load, all of this data in bulk, right? Or modify or purge data in bulk when you're managing all of this data, these large data sets that grow over time. And of course, security, right, is always top of mind. And can your fleet management system solution, employ end-to-end encryption of the data that you're accruing, right? Data, at rest and in transit. And from that infrastructure deployment view, your data may be secured, but are the fleet management systems that you employ, like the access rights, configurable enough that any given user only has the level of access to data that he or she needs, right? You're not over granting access to data and you're not restricting them from doing their job because they don't have access to data and finding that sweet spot. And, if data is automatically ingested through integrations, how are those data errors addressed, right? It's like errors happen, but being able to automatically catch errors and move those to some queue to be addressed manually by an individual, at a later date is important to be able to do that versus just losing that data into the ether. Are you able to generate unlimited key performance indicators against your data, right? And reports data within the system. So if the data is in the system and you can think of a question regarding that data, you should be able to build a report against it or a KPI, whether it's using the tools provided within that solution or having the ability to use any third-party reporting tool that you're comfortable with. And our, the integration protocol is plentiful, right? Does your fleet management system support APIs, flat files, ODBC, staging tables, right? And any general industry standard protocols to accommodate the technologies of external systems. So, and are you able to easily export the data out of the system, right? To support, larger organizational data lakes. For example, you should be able to go into the system, easily filter on a screen for a set of data, and with the click of the button to be able to export out to some comma delimited file or tab delimited file. Or leveraging APIs, be able to extract data through a comprehensive set of endpoints that are available to you, right? Or invoke some scheduled tasks, right, that would bulk load data to an external data lake based, again, on your organizational needs. So in the end, data is king, right? But being able to address, analyze, report against, and share that data is just as critical, and be able to do it in an easy, intuitive, seamless fashion. So while data is king, having access to that data in a fleet-centric single source of truth reduces time to identify and collect data otherwise, from disparate sources, right? Thus, removing data silos, right? And knowing that everybody is working from the same information and assumptions inherently improves, processes, accessibility, and control, right? Transparency and data accuracy. So to do this, a fleet management system must support, multiple means of integration. Spoke a little bit before, but, while APIs are the standard tool today, many industry standard protocols and legacy protocols do exist. So it's important a fleet management system support many or most of those industry integration protocols, as external systems often do not. So having that flexibility to use multiple different protocols improves your chances of being able to easily integrate, data with the necessary third-party systems. And as your single source of data set grows, so too does your ability to make informed decisions, right? And align goals across organization, because all of your, because you're all working from the same centralized reference point, right? And these data shouldn't just be recorded for vehicle details, right? Fleet employee data related to human resources or CDLs or tests or certifications and employee satisfaction surveys, right? They all play a critical role into the effective operations of your overall fleet department. And also, important data to capture may revolve around inventory management, not just like, what's on hand, but the processes in which you manage and deliver inventory to individuals, right? Short and long-term rentals activities of vehicles and how those operations occur. Not just the fact that you're doing that, but just getting insight is what was the right vehicle that somebody maybe should have reserved or what have you. Registration details, special fees, leases, insurance, warranties, right? The list goes on and on about all the metadata that you can accrue around managing fleet operations. Knowing your customer, drivers and operators of vehicles and equipment is equally important. Maintaining current data, tracking their requirements and their needs to perform their job responsibilities, and ensuring that the proper assets and supporting tools and equipment are available when needed, right? And obviously, having this information and leveraging and actioning it so that things are available when needed improves efficiencies, but it also reduces frustration and it fosters strong relationships with your coworkers. So some of this, may seem like unnecessary metadata, but it can be critical in making fleet right-sizing decisions and implementing new programs and being able to justify those decisions. For example, through telematics data, you may be able to identify clearly underutilized vehicles, right? And these vehicles can then be shifted over to a motor pool operation. Or understanding fleet-wide usage behaviors may lead to a decision to implement a brand new motor pool operation, right? You get the most bang for your buck to manage your assets that way. But if the fleet department does not have access to the telemetry data, because, as often is the case, the department doesn't own the tool, a fleet manager would never be able to make these determinations. It's not uncommon. A given organization owns 3 or more different telematics solutions, right? There are specific use cases for snow management, waste management, police. They all have these unique telemetry needs. But even if all of those unique systems are necessary in the organization, if you can collect the relevant fleet management data through integrations into your fleet-centric single source of truth, many of these insights wouldn't be missed. The importance of data-driven decisions, right? Paramount. And if, robust, accurate, comprehensive data sets, exist, in a single database, your ability to then make sound, defensible, data-driven decisions is greatly increased. And effort to support and improve data-driven decisions, it's important your system collect data from multiple disparate sources, right? I referenced telematics and a couple others, but also, there can be fuelmatics or fuel systems, DVIR processes, TPMS systems, fluid systems, right? And industry metrics outside of day-to-day operations from the likes of OEMs and NAFA and APWA and NHTSB, or, and then, through your ability, effective reporting tools to analyze all of these parameters, it just inherently leads to improved efficiencies. One example, telematics data, may expose, grossly inefficient routes taken between jobs, or what people are doing in between jobs, right? And if people are going from one side of the town to the other when there was another job maybe that was less than a mile away, that leads to excessive energy consumption and, more frequent maintenance activities. And that leads to potential more downtime and ultimately, a higher cost per usage valuation. But, uncovering the inefficient route, or common routes taken on daily activities, could be resolved by adopting practices that then assign crews to the next closest job, right, from where they're physically located, and to be able to use maps and GIS incorporated into fleet management systems can help facilitate those processes. So, and activating such processes would inherently lead to cost reductions, right? Through now you're using less energy consumption, reduced wear and tear, less PTO engagement. But if you're not analyzing the data from all the sources, making it easy to analyze by incorporating all the data into a single repository, the small adjustment, would go unnoticed, and you wouldn't be able to recognize those savings. So, as the saying goes, right, you can't manage what you can't measure, but also assuming your measurements are sound, right? Decision-driven, by objective evidence, they're always defensible over intuition alone. And while I think, personal intuition will always play a role, still important are the insights derived from sometimes, non-intuitive but objective data. Okay, to potentially be able to correlate and demonstrate unsafe driving behavior, with increased maintenance, right? It's not something you can do, managing two disparate systems. They really must be integrated. And where driver behavior issues may be identified through telematics systems, the ability within the fleet management system, right, to administer trainings, tests, certifications, all in effort to document that driver behavior improvements, are tangibly related to corrective actions, and in turn vehicle operation cost savings. It's important to be able to do that. Over time, these corrective actions, they can be demonstrated to reduce frequency of accidents through miles per incident statistics. And another example of data-driven decisions through data procured from disparate systems is you might have two of the exact same F550 truck or whatever the rig is. But one of them, if used regularly off-road, winter conditions, and the other is underutilized in a city setting, these assets would have, significantly different life cycles. And not collecting all the metadata around those same assets usage, the upfitting information, the repair history, all the fueling data, the telematics, and crew data, right? Interviewing crews and how they use it and understanding the specific crew use of a vehicle, right? And getting all of those sources, not having all that data from the different sources, would lead planners to make incorrect assumptions. And so you might get one vehicle that's replaced too soon and another too late. Same vehicle though. So it's important planners incorporate all the data possible when performing, Defender Challenger models to make repair replace decisions, as well as derive as accurate as possible target versus non-target projected maintenance costs. Okay, so the question is asked, why not let data dictate when a vehicle should be serviced, right? The blending of fleet-centric asset management systems with telematic solutions, right, has led to the deployment of these new predictive maintenance tools, right? Extremely large data sets allow for inferences to be made, that could be made otherwise, predicting when a component of an asset is likely to fail based on environmental parameters, the asset role, right, and how its part history compared with many thousands of other like assets. So from such inferences, service requests or work orders can automatically be created and notifications sent. This means that, the elements of longstanding established class PM programs can be rethought. And the net effect is, less dollars are needed for preventative maintenance activities, lowering the total cost of ownership and simultaneously lessening downtime. So as it relates to asset utilization, all fleets operate differently, and the utilization of any given asset varies widely. And, the necessity to maintain a given asset, despite whatever its overall utilization is, also varies greatly among organizations. But nonetheless, the ability to be able to analyze your fleet's unique utilization goals and do so, with any metric you define and having access to that data, right? The data itself is objective, but as long as it's accurate, they can be used to justify the subjective decisions, derived from them. Sorry. So, okay, I just want to switch over to a few, real world examples. And actually, apologize, did I? Apologize. Okay, thought I skipped over a slide there. A couple real world examples. For 17 years, the city of Oklahoma has used Fleet Focus, but until recently, technicians had to actually share computers. Lines would literally form to enter in work order details and other fleet related data. And needless to say, the water cooler effect was in full force. And modernizing the user interface to support phones and tablets allowed technicians to enter their work activities in real time while actually working on the vehicles, right? And the net impact of not having to wait for a computer and the small time savings of not walking back and forth between the bays, back and forth between two from the bays, the city's downtime was lessened by more than 2 hours a day. And today, tablets are essentially consumables, right? And the AssetWorks Edge interface, for example, can be used from any modern device, phone, tablet, laptop, whatever it may be. It improves efficiencies with streamlined touch-based workflows, and it supports functions like voice activation features, right? The ability to dictate notes. A lot of folks have a hard time, typing on those QWERTY keyboards on their phone, so you can just speak those notes. And speak to search and to look up assets and to look up work orders. So, and understanding there can be factors considered like unions mandating compensation for employees to use a personal device. Nonetheless, allowing employees to bring their own device lowers the barrier to easily interact with an organization's modern fleet management system. And it seems somewhat self-evident, but the act of printing, handling, sharing, and moving paper slows work processes down, right? And as is the case, with anything paper-based work orders, paper can be lost or damaged, especially in the shop environment. But for years, the city of Minot was doing just that, right? And they were doing that through a system that was not even designed or fleet requirements taken into consideration. So in modernizing by deploying a fleet-centric solution and adopting electronic processes and being able to work from a phone or tablet, now when somebody brings a vehicle in, that service writer can immediately open a service request or work order, immediately assign it to an available technician, right? And that technician then can take that electronically, right, instantly shows up on their iPad or their tablet device. and the technician can immediately perform their work activities, never having to see a piece of paper. And by adopting the electronic workflows, Minot was able to improve compliance, reduce data entry errors, and automate the collection, right? And reporting of data points such as asset downtime, delays, and utilization. These were all processes that used to take many weeks or months to collect and aggregate that data. These steps, they streamline human processes, but when you marry them with the electronic workflows, with vehicle telematics, predictive analytics, and other techniques is when you really start to see the efficiency soar. Perry and Sons, they use mobile fuel tankers, and other than writing it down on a piece of paper, there was no accounting for fuel going into ag equipments in the field. And with many seasonal employees, it was hard to track, which individuals were fueling assets. And again, if you can't measure it, you can't manage it. So by implementing a mobile solution to track fuel transactions a lot electronically in the field, Perry and Sons, can see now for any asset who fueled it, when, what fuel type was entered, and at what cost, right? Previous insights were limited to how much fuel did we buy from a local vendor, right? And now, inclusive of all the transaction details, insights, regarding the potential misuse of fuel, or perhaps identify poor performing assets, burning too much fuel, can be gleaned almost immediately. So to recap, in the end, you want to be able to collect accurate data from as many sources as possible, right? And whether it be manual entry or full automation of data, it should reside in a single source of truth. And a single source of truth that is intuitive to use, easily accessible, and all given proper access rights. And, you want your system to be easily capable of sharing data, right? And developing any conceivable report, right? And then being able to present and justify those inferences of the data, having confidence, that the data is accurate and comprehensive. So again, regardless of the constantly evolving and changing fleet landscape, it's the ability to manage from a single source, a comprehensive and accurate set of data. It goes a long way in future-proofing your fleet. So those are my thoughts and comments for the day. I will hand it over to Mary Ellen with any questions and go from there.
All right, perfect. Thank you, Jim. All right, everyone. So like Jim said, we're going to open up the floor for some of your questions. So as a reminder, if you have any more questions at the time, please use the WebEx chat tool on your screen. If we have enough time, I'll pass your question to Jim, and he'll be happy to give you an answer. But Jim, we did have a couple questions come through. The first one being, if you had to speculate, how do you see AI tools impacting fleet in the next few years?
Excuse me. There's many ways it could. I would say, one, the evolution or continued evolution of predictive tools, right? There are things like brakes and state of battery that are the low-hanging fruit for those predictive tools. But as the data models get trained more and more, you're going to see more specific, parts of a vehicle that are going to start exposing, that kind of information. So it's just an evolution of predictive tools. I think initially, what would be a low-hanging fruit in terms of applying something against a fleet management system is the ability to use natural language to create reports, right? So I might be able to speak whatever information I want, and it could automatically just spit out a nice, pretty picture and the raw data supporting that graph, gauge, or chart. Or say you're looking for a particular metric, KPI, and you could speak or write that, and it would write the select statement that you could then run directly against the database to be able to do that. So those are the kinds of things, I mentioned, they're available effectively today. It's just the engineering task of applying those, to fleet management systems.
Great, thanks, Jim. Another question came in. Are you or is AssetWorks going to be attending either NAFA or GFX coming up?
Yes, both. We will both be there. I will be at both.
Okay, perfect. I think people might be asking you questions on site at those shows. All right, perfect. And it looks like that's all the time we have for questions today. So I would like to thank you all again for attending today's presentation. Hopefully you've secured some valuable takeaways to keep in mind moving forward. Jim, I would like to thank you on behalf of AssetWorks once again for sharing your expertise with everyone today. If you guys have any other questions, then definitely reach out to Jim or anyone on the AssetWorks team. And in the meantime, I hope you all have a great day, and we look forward to having you with us next time.
Thank you, Marianne. Thanks, everybody.
Yeah, thanks, Jim. I'm going to stop the recording now.